Hi everyone, this is video for day 4, so the last series for this week. We ended day 3 with this interesting observation regarding what happens when you multiply these functions, and we see that there's some sort of wrapping, like a beautiful pattern emerges where these functions which replace the amplitude form a boundary for the cosine and sine function. So to view the product of two functions, if hx is sinusoidal, which is a generic name given to a sine or cosine looking graph function, and gx, a negative gx, can be viewed as a boundary. Now without the use of Desmos, guess what this would look like? Think of this as the boundary and this as the original function. So if you plot it out, the time, you can look at the time periods of these functions. The boundary is going to have a time period of 1, right? So you would expect the smaller function to be wrapped up inside. And then you can verify using Desmos, which you have, you now hopefully have played around and know how to use. This idea is used as a very important application in transmission of signals. Now the sound that we hear is actually waves, and it's a sinusoidal wave. And the way we perceive it is that we have this eardrum which hears this wave and it vibrates in the same frequency, and that gets converted in our head as sounds. So if you use any app for recording, and there is a free app called Audacity, and you can look at it, it generates the actual graph of your voice as you record, and you will see it's going to be sinusoidal. Now transmitting them is or was a great big challenge, because over long distances you can lose a lot of the information. And so the idea of modulation, which you probably heard, like you've heard of FM radio in your car, and there used to be this something called AM, which still some of the older cars have, and this is nothing but exactly what we just learned. It's a method in which you can transmit the signals without losing them. Okay. So what you do is you have your sound wave, which is your original wave. This is your, let's say, your information. But it's one single wave, so if you transmit it, it might get lost. So what you do is you use a signal wave, which is like a really, let's say, low frequency wave. And the first method is called AM, which stands for amplitude modulation. So what you do is you take this sound wave as the boundary, and you use a signal wave inside it. So what is happening is the signal wave has varying amplitudes, right? As you can see over here, it's higher, it's here lower. So now, because this is the signal you want to send and it's weak, what you do is you send this high frequency signal which wraps around it, which makes it strong. It sort of facilitates the transmission. And you do this exactly by multiplying, like we just saw. And this method is called amplitude modulation. And the second method is called frequency modulation, which is slightly different than multiplication. In this case, you keep the amplitude constant. So you still have the same amplitude, but what you do is you take the sound wave and they just have varying frequencies. And the frequency varies according to the sound wave that you want to transmit. So this one is not exactly what we saw in the graphs, but just to give you an idea of an application of multiplying these trig functions, and also how they are used for transmitting information. That's the end of this video. The last thing we need to talk about for this week is graphs of the other 4 trigonometric functions. So in the next video we're gonna analyze them and see what they are supposed to look like, or what we expect them to look like. And then you can use Desmos to verify that it actually does look like that.